welcome to the Elvatech YouTube channel. Today, we are gonna talk about environment because environmental issues are becoming increasingly important in modern society. Pollution caused by heavy metals and toxic elements threatens not only nature but also humans' health. Industrial emissions, contaminated soils, and toxic waste are serious environmental problems that require precise and rapid monitoring. X-ray fluorescence analysis, or XRF, is one of the most effective and convenient methods for environmental monitoring. It allows you to quickly and accurately determine the presence of hazardous elements in air, water, and soils. Today, we will explore how XRF helps detect pollutions, what challenges it addresses, and why this method is crucial for environmental protection. Environmental pollution is not just a threat to the nature. It poses a serious risk of humans' health. Heavy metals such as lead, cadmium, mercury, and arsenic can accumulate in soil, water, and air, poisoning ecosystems and entering the food chain. For example, industrial emissions contain heavy metals that settle in the soil and can contaminate groundwater. This affects drinking water quality and agricultural products that we consume. To prevent such consequences, regular environmental monitoring is essential. This is why environmental control is mandatory for industrial enterprises, municipal services, agriculture, and environmental organizations. But traditional laboratory analysis methods can take a lot of time. XRF provides accurate results on site in just seconds. Let's see how it works. X-ray fluorescence analysis, or XRF, is the method that quickly and accurately determines the elemental composition of various materials. But how does it actually work? Well, it's simple. The analyzer emits X-ray beam that interact with atoms in the sample. Each element responds by emitting a unique fluorescent signal, which the device detects and analyzes. As a result, we obtain presence data on the contamination of various elements, including heavy metals, toxic impurities, and essential micronutrients. The main advantage of XRF is its speed and convenience. For example, we can check soil for contamination on site without sending samples to the laboratory. Unlike traditional methods, which can take days or even weeks, XRF analysis provides results in just seconds. This is especially crucial in field conditions, where quick decision-making is essential. XRF is widely used for environmental monitoring in various fields. Let's look at the key areas where this method is dispensable. First, for sure, it's soil analysis. It helps detect toxic elements such as lead, cadmium, and mercury, which can accumulate in agricultural lands and pose a health risk. Second, water analysis. XRF detects heavy metals in water, which is critical for monitoring drinking water, wastewater, and industrial effluents. Third, air analysis. XRF is used to monitor pollutant emissions from industrial facilities and track hazardous elements in the atmosphere. Another important application is raw material control. For example, in construction materials production, it is crucial to ensure they do not contain radioactive or toxic impurities. Additionally, XRF is actively used in waste recycling. It enables efficient metal sorting and hazardous component monitoring in waste materials. As you can see, XRF analysis is the universal tool for environmental control, providing fast and accurate pollution detection across various industries. And now, let's head on to our experiment. Today, we have a sample of a soil. And first of all, before we start our experiment, we need to cover up some things. When we work with the liquid or powder samples, it's always better to use a special cuvette to keep them here. And also, we need to make sure that we will have no impurities and everything is covered directly as needed. Because if there are going to be any contamination to the device and for some reason you won't have the protective film here, it might get to your detector and your tube. And trust me, you definitely don't want it because all repairs in this field gonna be really expensive. So let's move on to our experiment here. And first of all, we need to check as safety first. All we need is our cuvette and our napkin. That's it. So firstly, we need to check all the areas if it's covered tightly and accurately. Here we can see that no contamination can be poured from the sample. Let's just shake it a bit and try to tap it onto our napkin. Just maybe slide to understand if there any contamination poured from the sample. So now everything is covered up tightly. We have the absolutely clean napkin, so we can take it apart and start our analysis. We position it on our lab stand because we really need the lab stand for this. It's always better to work with them when you work with soils or like powder samples and liquid samples when you're using cuvettes, in different words. And let's go back here to our device because we need to choose our calibration and the duration. Our calibration is called the soil ores, and the duration of analysis we can set up for 5 seconds as usual because it's absolutely enough for fast check-in. Right, seems we are done, everything is ready, and we can start our analysis. And we are done with our analysis, and let's just check it because something is really strange and doubting me. Well, first of all, we have all analysis, all data is going to be in ppms, part per million. And here we have iron is the leading element here in the amount of 24,830 ppms. Then we have calcium, which is absolutely good for soils, in the amount of 15,000 ppm. The next one is calcium. We have 7,600 ppms. Then titanium in the amount of 4,030. And the next element is what looks really strange. Not the element itself, but its contamination in this sample. Here we have lead in contamination of 3,160, which can mark the soil as pretty dangerous, and it's need to be cleaned up. The next one we have manganese in the amount of 580 ppms. And the next one is zinc, which is also not that good. But the contamination of it are pretty small. We have 314. All other elements, I just can mention them a bit, but here we have really a lot. In this particular sample, we have really a lot of different elements. So, summarizingly, looking up to this sample, we can say that that quantity of mentioned elements in it, and some of them are getting up to a strange amount, like lead. It's basically, we can say that here we can have a technical contamination. So it's more not of a nature, but of some industrial pollutions and all the stuff. So this kind of sample from this soil, it's better to be checked again, and it's better to be cleaned up. Today, we explored the importance of XRF analysis in environmental monitoring. This method provides fast, accurate, and non-destructive analysis of various materials from soils and water to industrial emissions and waste. With the portable analyzer like the Prospector 3, research can be conducted directly in the fields, eliminating the needs of laboratory testing. This enables quick decision-making and prevent environmental pollutions. If you need to comply with environmental regulations, monitor raw materials quality, or ensure environmental safety, XRF analysis is your reliable solution. Want to learn more? Drop your questions in the comments and we'll cover them in future episodes. Subscribe to our channel and stay uploaded with new information videos, and don't forget to like this video so we know you like it. Stay tuned and see you soon.